Good day, friends. Today I am here with another video in the pump series. I am going to talk you about axial flow pump, its maintenance, troubleshooting. So as you can see in this one only, I will tell you about the parts associated. You can see here, this is the main shaft. This shaft is the main shaft. Here you can see the gland packing which is being provided, which does not allow the liquid flow outside. So this is the gland packing provided. This is something which is your bearing housing. You can see this is your thrust bearing here, and this is the another bearing on which the shaft rotates. And then finally you can see it is attached with the impeller, and you have this impeller arrangement. It looks like a ship's propeller. And this is the diffuser piece which is attached in the suction, and here these things are detachable. So this side the suction will be there, and this side you have the discharge. So if we have some maintenance issue regarding the impeller and all, so we can detach this section and do the rest part of it or the maintenance part of it. So this is something which is the structural description of the axial flow pump. Here you can see the description part. An axial flow pump, it is also known as propeller pump. It is basically the centrifugal pump, and basically it is designed for moving the large volume of the liquid and less head. Means the pressure, or you can say the head, is not much required, but the volume discharged or the volume delivered will be huge. Unlike the radial flow pumps, this is something which discharges the fluid perpendicular to the shaft. Now the axial flow pump, it provides the fluid parallel to the shaft. So that's why it is called axial flow. It is along the axis of the shaft. This uses a screw propeller like structure axially, and accelerates the liquid. The outlet passage and the guide vanes are arranged to convert basically the velocity into the liquid pressure. Okay. Okay, in continuation now, the pump casing is split horizontally or vertically to provide access to the propeller, which I have already explained in the drawing. If any maintenance required to be done on impeller, we can split it and do that. Mechanical seal also, this basically prevents the leakage with the shaft. Okay, and the thrust bearing of tilting pad type is fitted in the driving shaft. The prime mover may be electric motor or maybe a steam turbine, because it is a huge pump. It is a large pump. Okay, here in this diagram you can see this is just like a propeller. Okay, so this is just like a propeller which is being fitted over here. This is the suction side, and it is going to give the discharge like this. So liquid is going to pass through the axis of the pump. So that's why it is axial flow pump. Here you can see this is your means this is something which is, you can say, the seal arrangement, shaft seal, which will prevent the liquid to discharge or leak to the other side. And here you can see the clamping arrangement, the bearing housing and all. And then finally this side you have the prime mover attached. Here you have the foundations attached. Okay, so this pump also known as propeller pump. Here you can see it looks like a propeller. They are efficient, simple in design, available in wide range of capacities. Propeller pumps are ideally suited for the condensers, where they offer low resistance when idle. Okay, so this is the part. Principal operation, it is axial flow pump which is having impeller. Basically it's a centrifugal pump only. The impeller rotates and the blade exerts the axial force on the liquid. This creates a lift effect similar to an airplane wing, because it's a propeller type. Okay, and pushing the liquid in a straight line along the axis of the shaft pump. What are the various key components? As you have seen in the earlier diagram, impeller, this is the rotating part, blades type, vanes type, casing with diffuser arrangements, this outer cell that houses the impeller, from where the suction is there. You have the diffuser arrangement also. Okay, so includes the stationary guide vanes and redirects the swirling fluid through the impeller into the straight axial flow. And by doing so, it converts the kinetic energy into pressure. So what happened? Basically, this gives the kinetic energy into the pressure energy. So if this kinetic energy is imparted by the impeller due to its structure, as it's like a propeller part. Okay, shaft, the mechanical component that connects the impeller to motor or engine. Okay, so this is the shaft and it is attached to the prime mover. It can be the steam turbine, it can be the electric motor also. Suction and discharge. Suction is from the front side and discharges up. Okay, so entry and exit points I have shown you in the diagram also. Designed to basically minimize the turbulence and maintain the linear flow of the liquid. What are the main characteristic? As it named earlier, the axial flow pump, and it is designed basically for the high flow rate. That means the quantity of discharge will be high. It's a massive amount of the liquid or water or cargo, whatever is being supplied. Low head, generally the pressure is requirement is not much, and the high elevations are not there. High pressure requirements are not there. Okay, so it is not not efficient for high pressure part, and it is efficient for large quantity but low head. The specific speed, the pump have high specific speed, making them very ideal for high volume and low pressure applications. Performance curve. Performance curve, basically every centrifugal pump have the performance curve, but in this one you have seen the power requirement is very it's highest at the zero flow rate or at such a shut off. When it is shut off, the power requirement is very high because in the inertia is also there, and in the starting part it takes large current. Therefore these pumps are typically started with a discharge valve open to prevent the motor overload part. So initial inertia is very high. Marine applications. What are the various marine applications? Sewage treatment. In passenger ships, you have the large amount to be handled. So this type of the things is possible. Or in shore also you have seen the handling of large amount of the effluents. Marine operations, large scale of cooling water circulation for the ship's engine or ballast water treatment arrangement also it can be possible. Chemical processing, large amount of liquid in evaporators or crystallizers or the chemicals which has to be discharged. Condenser circulating large amount of liquid for the condensers. This is also possible with these type of pumps. Now the most important thing is what are the maintenance criteria. So daily checks, visual operations basically required. So check for the vibration and noise. Yes. Monitor the operating parameters like your suction pressure, discharge pressure, amount of current which is being taken, flow rate, all this part. Temperature tracking. Feel or use of IR, infrared thermometers, bearing housing and motor, and detect the overheating. When you are taking the daily rounds, you must check this. Visual leak inspection. Yes, there is a shaft seal arrangement. So check for the stuffing box or mechanical seal for sudden leaks part. Okay. Vibration also, some vibration meters also on board ship we have, and you can put on the engine part, motor part, and see that the vibrations are not much, well within the limits. Monthly check or quarterly check. Lubrication, yes. Oil reservoir with must be filled up with the grease or the motor bearings. Avoid over greasing of it. If the grease cups are there, avoid over greasing of it. Otherwise, it will cause the excessive heat buildup. Shaft and coupling alignment. Verify the alignment between the pump and the prime mover, that is your motor or engine, whatever it is there. And if the misalignment is there, it will destroy the bearings and the couplings also. So basically shaft and coupling also to be checked. It should be aligned. And the best indication is your vibrations and noise. Fastener check. So any base part or the coupling part or any other nut bolts which is attached to the suction part or the discharge part, holding down bolts, also casing bolts, foundation bolts. So this must be perfect. So tightness also has to be checked. High volume axial flow pumps are prone for loosening from the structural resonance. So as this is a huge pump, so this needs to be checked for the fastener arrangement or the check. Check the immersion depth. It is if it is a vertical wet pit type axial pump, ensure that the minimum submerging level must be maintained. Otherwise, pump does not draw air vortices. Okay. So, what will happen if the sufficient immersion of the pump will not be there? Then what happen? It can draw the air part, and then it is a difficult issue. So, as it is a centrifugal pump, it is not being capable of handling the air or the vapors. So, we have to take care of it. Annual and measure overall. So the impeller inspection we have to do, pump inside inspection, clearance measurements we have to do, bearing and seal renewal if required we have to do, and if the excessive noise and vibration, then dynamic balancing also we have to do. So impeller inspection, in that one, the rotor assembly has to be checked. Impeller blades also has to be checked. The erosion part, cavitation part, pitting part, and any other cracks or any other entrained debris that needs to be checked thoroughly. Clearance measurement, measure the critical clearance between the outer edge of the impeller blades and the casing liner. And excessive clearance drastically drop the pump efficiency. Yes. So in that case, if it is excessive wearing out, then the impeller needs to be replaced with a new one, or otherwise, if it is excessive clearance between the impeller and the casing, it will reduce the pump efficiency. Bearing and seal renewal, yes, as per the running hour, the replacement of the mechanical seal, replacement of the packing rings, sleeve bearings, whatever it is there, it has to be replaced. Thrust bearing also. So whenever the running hour comes, must replace the bearing part. And seal also. Okay. Dynamic balancing, if the impeller has undergone the repairs or the heavy erosion, it must be rebalancing for assembly or preventing the severe vibrations. So whenever you have excessive vibration or whenever you have the noise and all, so it is better to do the dynamic balancing of it, or if you have impeller change or any bearing arrangements and all, so it must be balanced. Okay. Troubleshooting guide. This is something which is very important part. So this will give you the detailed information regarding the troubleshooting. So we will go one by one cause. You can see low flow rate and the discharge pressure. This is one of the symptoms. This is one of the problem. If the flow rate reduces or the discharge pressure, whatever is there, that also reduces. Then what are the potential causes? Clogged or fouled impeller blades. Yes, this is one of the thing. Then what happens? Shut down and clear out debris from the suction side and impellers. So if you find this clogging part, so it will be clear and then it will be okay. Impeller clearance are too wide due to wear down. So if the impeller wear down or the internal casing part, then renew the casing liner or adjust and replace the impeller blades. So this has to be done. Entrained air or insufficient submergence. So we have discussed just now in the previous slide that we have to have the sufficient submergence of the pump, otherwise the air can enter, and this is a centrifugal pump, it cannot handle air or the vapors. So increase the water level or modify the intake structure so that the impeller and all these things must be fully submerged. Incorrect motor rotation direction. This is also the thing. So then in that case, the reverse the phases and check the terminal box and see that the required discharge pressure is being attained. So these are the potential causes and these are the corrective actions which if you apply, you will get the desired result, and the problem of the low flow rate and the less discharge pressure or the low discharge pressure will be solved. Now with the another symptom. Another symptom is your excessive vibration and noise. As during this video, I have already discussing about that if you have excessive vibration, excessive noise, what could be the cause and all. So first of all, we will see the potential causes. Misalignment between the pump and the motor shaft. Possible, it can be possible. So then we have to realign using the laser alignment tool or with the dial indicators. Imbalance impeller due to the uneven wear or debris, or when boxing back, it is not being fixed correctly, uh, some problem. So clean the impeller and do the dynamic rebalancing. Cavitation, yes, insufficient NPSH or very low suction head due to the cavitation. Then in that case, lower liquid temperature or the fluid temperature, clean suction strainers or raise intake level. So this can cause the removal of cavitation, or the cavitation will not happen if it is deeply submerged. Loose foundation or mounting bolts. Yes, we have seen in the maintenance part, we have to take care of it. So because in this pump, it's a huge pump, large pump, due to the vibration, the foundation and the mounting bolts can lose. So tighten all holding down bolts with the proper specification. That means if you are doing the hydraulic tightening and all, so see, as per the manual, you have to do it. Another one is your bearing overheating. Yes. So what is the potential cause? Insufficient or degraded lubricant. So lubrication we have to take care of. That is also one of the maintenance part or the maintenance check. We have to make sure that sufficient lubrication should be there. Then in that case, what the corrective action? We have to flush out the old grease and all and refill with the correct grade and correct amount. It should not be more, it should not be less. So it should be as per the manuals. Over lubrication, grease churning. So excessive lubrication also create problem. Relieve excess grease through the relief plug, and then what will happen? It is going to normalize the problem. Shaft misalignment, putting heavy radial loads on the bearings or the thrust bearings. So shaft misalignment has to be checked and dynamically rebalanced. Reverify the shaft alignment and check for the bent shaft. Next, now we are checking the severe leakage at the shaft. That means the mechanical seal or the stuffing box arrangement, the sealing arrangement is severely leaking. So worn out the gland packings or the mechanical seal. If the gland packing is worn out, then in that case, replace the packing rings. And if the mechanical seal is there, then the replacement of mechanical seal is also possible. Then the problem will be solved. A scored or pitted shaft sleeve. Yes, for long run, then this is also possible. Then it is a matter of large time taking work. That is something which you have to machine or replace the damaged shaft sleeve. That has to be take care of. Excessive shaft run out or wobbling. This is also the problem, wobbling problem. Check bearings and balance to the correction of the shaft deflection. So if it is there, then the wobbling effect will not be there. So some problems we have discussed. Now the another one, motor overloading. That means if you see the amperage, we have to, when we are doing the maintenance or the checks, daily checks, the suction pressure, discharge pressure, vibration, noise, and the amperage. Amperage is also going to give you a good indication. High amperage, high amps. So what are the potential cause? Operating at the head higher or lower than the design point. So axial pump draw maximum power at shut-off or the higher heads. Okay. So higher head will give the very high amperage or overloading of the prime mover. So ensure the discharge valves are fully open, number one, and number two, never run an axial pump against the closed valve. Then in that case, the due to overloading, the motor will trip, and if the tripping mechanism will not work correctly, then it can burn also. Packing glands is over tightened. Yes, during stuffing box, the gland packings, it needs to be slacken up and see that the not excessive leakage and not over tightening also. So you have to, with your professional judgment, you have to maintain in between. So back of the gland nuts evenly until the slight cooling drip is achieved. Means some amount of the water will come, and it basically gives the cooling aspect also. Internal rubbing between the impeller and casing. Yes, this is something which is one of the alignment part. So if it is the casing and the impeller is touching, so now noise and vibration both will happen. So balancing needs to be done, clearances needs to be checked, and shaft straightness is also needs to be checked. So I hope I have described about the uh, description of the axial flow pump, the major components or the key components, and then operational part also we have discussed, and regarding the maintenance checks, um, daily, monthly, quarterly, annually, we have done all these things. And finally, which is very important, which can be asked in your oral part, that is your troubleshooting. So what are the possible cause and what are the remedial actions? So that I have also described. I hope it is going to give you a better idea about the axial pump. And please keep continue. I will come back with the pump series. This is my pump series. So same like that, I will come with the other type of pumps also. Thank you.